Hello and welcome to Medical Dialogues, your daily dose of health and medical news. I'm Mr. Zaman and here is what I bring to you all from the world of medicine. Increased heart disease risk from red meat. Chemicals produced in the digestive tract by gut microbes after eating red meat may help explain part of the higher risk of cardiovascular disease associated with red meat consumption, according to the new research published in the American Heart Association's peer-reviewed journal Arteriosclerosis, Thrombosis and Vascular Biology, or ATVB. Previous research has found that certain metabolites are associated with a greater risk of cardiovascular disease. One of these metabolites is TMAO, or trimethylamine N-oxide, which is produced by gut bacteria to digest red meat that contains high amounts of the chemical L-carnitine. High blood levels of TMAO in humans may be associated with higher risks of CVD, chronic kidney disease, and type 2 diabetes. However, whether TMAO and related metabolites derived from L-carnitine may help explain the effects of red meat intake on cardiovascular risk. To understand these questions, the researchers conducting the study measured levels of the metabolites in blood samples. They also examined whether blood sugar, inflammation, blood pressure, and blood cholesterol may account for the elevated CV risk associated with red meat consumption. Study participants included nearly 4,000 of the 5,888 adults initially recruited from 1989 to 1990 for the cardiovascular health study. Several blood biomarkers were measured at the start of the study and again in 1996 to 1997. For the current analysis, the researchers compared the risk of cardiovascular disease among participants who ate different amounts of animal source foods, that is, red meat, processed meat, fish, chicken and eggs. They found that eating more meat, especially red meat and associated processed meat, was linked to a higher risk of atherosclerotic cardiovascular disease, a 22% higher risk for about every 1.1 serving per day. According to the authors, the increase in TMAO and related metabolites found in the blood explained roughly 1/10 of this elevated risk. They also noted that blood sugar and general inflammation pathways may help explain the links between red meat intake and cardiovascular disease. Blood sugar and inflammation also appear to be more important in linking red meat intake and cardiovascular disease than pathways related to blood cholesterol or blood pressure. Intake of fish, poultry, and eggs were not significantly linked to higher risk of cardiovascular disease. Prevention of recurrent kidney stones by high in calcium and potassium diet. Changes in diet are often prescribed to prevent recurrent symptomatic kidney stones. However, little research is available regarding dietary changes for those who have one incidence of kidney stone formation versus those who have recurrent incidents. Mayo Clinic researchers designed a prospective study to investigate the impact of dietary changes. Dietary factors were based on a questionnaire administered to 411 patients who had experienced first-time symptomatic kidney stones and a control group of 384 people, all of whom were seen at Mayo Clinic in Rochester and Mayo Clinic in Florida between 2009 and 2018. The findings, which were published in Mayo Clinic Proceedings, show that lower dietary calcium and potassium, as well as lower intake of fluids, caffeine and phytate, are associated with higher odds of experiencing a first-time symptomatic kidney stone. Of the patients who had first-time stone formation, 73 experienced recurrent stones within a median of 4.1 years of follow-up. Further analysis found that lower levels of dietary calcium and potassium predicted recurrence. The takeaway as per authors is that patients should add more fruits and vegetables that are high in calcium and potassium to their diets. Fruits that are high in potassium include bananas, oranges, grapefruits, cantaloupes, honeydew melons, and apricots. Vegetables include potatoes, mushrooms, peas, cucumbers, and zucchini. Disordered eating in children. A new study of nearly 12,000 9 and 10-year-olds published this week in JAMA Pediatrics provides key insights that will help fill the gap. Researchers examined how age, sex, weight, and puberty stage were related to behaviors such as binge eating and vomiting to control weight. The first major takeaway is that these behaviors are more common than we have seen before, with a prevalence of up to 5% in some cases, said the study's lead author Stuart Murray. Contrary to the cultural assumptions, the researchers found that boys and girls were equally likely to engage in disordered eating. The analysis also revealed that children with high body mass indexes, as well as those further along in puberty, faced an elevated risk. The findings help outline the scope of the problem in this age group and point to biological risk factors that may ultimately lead to more targeted solutions, Murray added. Children further along in puberty faced elevated odds of taking measures to prevent weight gain. The researchers also found that children with higher BMIs were more likely than lower BMI children to engage in all disordered eating behaviors studied, that is, binge eating, vomiting, and taking other actions to avoid gaining weight. The study's results can improve eating disorder prevention by highlighting who is most at risk, Murray said. For example, pediatricians and middle schools may choose to increase monitoring and screening of children with high BMIs and children who begin puberty before their peers. Fast-acting immune cells, which provide powerful protection against stroke. A unique subset of WBCs confers fast-acting and lasting protection against ischemic stroke in mice, University of Pittsburgh neurologists and immunologists reported in the Journal of Clinical Investigation. The study identified a novel subset of CD8 plus regulatory-like T cells or CD8 plus TRLs as first responders to stroke. Attracted to the site of ischemic injury by a unique homing signal released by dying brain cells, CD8 plus TRLs reach the brain within 24 hours after stroke onset, where they release molecules that provide direct neuroprotective effects as well as limit inflammation and secondary brain damage. Because the previous two treatments must be administered very early after the stroke, many people, especially those living in remote areas, are ineligible for those therapies. The remaining 6 lakh people are left with symptoms-based treatments and are at high risk of developing long-term health complications, including mobility challenges and, in some cases, speech and cognitive pathologies. In addition, blood clot busting therapy in particular has drawbacks that further limit the number of people benefiting from such therapy. The immune response plays an important role in stroke. As soon as a blood clot wedges itself in a blood vessel, the brain sends an SOS signal to activate the immune system. The rapid immune response aims to clear out the cell debris, limit brain damage, and kickstart brain repair processes. However, the function of the immune system is diverse and complex, and different types of immune cells may play distinct beneficial or detrimental roles in a damaged brain. As Chen Hu and their colleagues showed, for the first time, the CD8 plus TRLs enter the brain much faster than any other regulatory immune cells. Within 24 hours after researchers depleted these special CD8 plus TRLs from the bloodstream of stroke mice, the size of the brain region affected by ischemia expanded by 50% compared to animals whose CD8 plus TRL levels remained intact. Even more reassuringly, mice who received a transfusion of purified CD8 plus TRLs prepared in the lab fared better and recovered faster than those who were untreated for over 5 weeks. These unique CD8 plus TRLs therefore serve as early responders to rally defenses after stroke and may collaborate with other immune cells to safeguard the brain for a long time. That's all for today. Stay tuned to Medical Dialogues for latest updates.
Never miss a medical update from Medical Dialogues. Like, subscribe, and press the bell icon.